G'day viewers, Alan here, welcome to the workshop. Well, Christmas is in the rear view mirror now, and I've been back out in the workshop working on my engine. So this is episode 7, I believe, in my Webster journey. And I can start this video by fixing up a problem I had with the a 50-tooth gear, which was covered in the previous episode. Anyway, got that sorted, and also made some progress with the ignition system. So let's dive in, and you can follow along. So I'm going to recut the 50-tooth gear, and I'm just re-examining or having another look at the piece of material that I used, the mystery metal, and I realised we've got these features here, and I think they must have been welds, and my carbide tools didn't have any trouble with them, but I suspect that the M08 M0.8 cutter didn't like it very much, and so this business here might well account for why I've got two very short patches of teeth that aren't right, because I think the cutter might have not been able to make proper headway through this stuff. I mean, I don't know what this metal is, it's just something that's been lying around forever. So I decided to use another piece of mystery metal. This piece here is about a 2-inch diameter bar, and I literally fell over it in some long grass near where I used to live. That was a long time ago now though, many decades. Anyway, it's been hanging around, and I had a go, and it actually cleans up and machines, as you can see, really nicely. So I think I'm going to do a lot better, and there's no weld marks on that. So I'm going to make another 50-tooth gear from this material. .609. That's less than half a thou, but I don't have much clearance between these two gears, so actually I'd rather it be probably half a thou undersized than half a thou oversized. Maybe I'll leave it the way it is, cut the gears, and then if I need to I'll do a bit of a clean up afterwards. I think that's going to be the plan. Alright, anyway, that's the OD of the gear, so now I've got to cut a spigot on the front, which will be what the cam gets pressed onto. Yeah, now we're talking 10.01. Okay, so all set up now to cut my 50-tooth gear. Hopefully it'll work out better this time. Well, let's see what happens. So I'm going to run the cutter at 200 RPM this time, which is a little bit faster than before. Let's see if that helps. That first tooth sounded quite good actually, the way the cutter was working, and I think it's as a combination of running the cutter a bit faster and steel that's not been messed about with welding. Anyway, now I have to advance on to the next tooth position. So with this dividing head, which has a 40:1 gear ratio, I just have to do 16 holes each time. So let's do our first advance. Oh, we've got to take the brake off. Let's do our first 16 holes. Round to there, and then advance this ready for the next one, and lock it, and we're good to go again. And now I just have to repeat that 49 times.
So I'm cutting the last tooth here, and it all seemed to go pretty smoothly, although I think the cutter is showing a bit of wear and tear from the encounter with the hardened stuff in the first 50 tooth gear, and you can see that there's a bit of a beard on the back of the gear, but nonetheless it seemed to work all right. So with that finished, it's time to whip the gear out, clean it up, and see how well it meshes with the 25 tooth gear.
Alright, so I've shaved its beard off and cleaned it up. And let's see how we get on with meshing. There's a bit of a burr around the hole on the end here, I think. That is a pretty good fit on that shaft though, so I might yet need to loosen that up a little bit. Anyway, it's not going to be a problem with checking the meshing. Alright, so I put this gear on previously. Let's see how it all lines up. Oh, I'm pretty happy with that. Yeah, that's very good. Okay, so I can put it all apart again, because I've got to press the cam onto the back of that big gear, and also I've realised I've got to drill holes in here and here for lubrication, so I think I might do that next. Okay, so it's time to press the cam onto the gear. I don't know how well you can see that, it's just sitting on there at the moment. But I tried to tidy the profile up a little bit and make the transitions a bit less dramatic. Alright, well I think that's going to be a pretty reasonable fit on there, press fit, but I'll put some Loctite on there anyway, I mean why not. Alright, so we've got that, something like that. So I think you could probably see from the table deflection that was taking a bit of a push to get that on there. Certainly squeeze the goo out, so let's give that a bit of a clean up. And there we have it. Alright, so I've got started assembly now. You can see the gears are meshing nicely. Now it was suggested in response to the issues I had in the previous video that it would be an interesting idea to try to run a piece of paper through and use that as a way of checking the clearance. Well, that's running through, but it's definitely consumed the available space. So I think that's giving us a pretty clear indication that the gears are meshing quite closely. But the paper did go through, so there is clearance there. But it's certainly just the thickness of that paper certainly made a difference to the amount of effort required to turn this. But it turns freely, so I think I must have the clearance just about right. I certainly wouldn't want to have less clearance anyway. So happy with that. Okay, so turn my attention now to the end float in these shafts, and I've made and fitted a simple bush here to the correct thickness. I think it was 4.4 millimeters, something like that. Anyway, and that's taken the end float out of the flywheel on that shaft. It's good. And now I want to do the same down here for this big gear. You might have noticed while I was spinning it around, this gear has moved away from its position. So I want it to be about there. And using a feeler gauge, worked out that I need to put a shim in between this gear and the side plate that's about 10 thousandths of an inch thick. So the question is, how do I make such a thing? So I've cut a circle or a washer out of a piece of 10 thou thick shim stock, and you can see it's pretty scruffy around the edges. So to clean that up, I have an arbor that I used earlier in this project with a 6mm shank, and that's the diameter of the axle that this thing has to fit on. So we can put that on there. Now I've machined up a pair of these bushes to the required OD, which will allow me to sandwich that bit of shim stock. We'll tighten that up, put it in the lathe and clean that OD up to match the diameter of these two bushes, and we should have the required shim. Now the OD of this washer isn't very important. I've set these at 15mm, and this just needs to be somewhere in that range. So I'll just take a light cut across the face of these two, and that's going to be, I think, will be good enough. Yeah, I think that's smeared it a bit rather than cutting it. I have to cut a bit deeper, I think. Yeah, I think that's done the trick. Okay, with that washer made, we can get a bit further ahead with the assembly. And we'll slip him on there. Just hold that rocker up so I can get that on. Now we should be able to get the this big gear on. Just snug fit over the end of the shaft. Hold that out of the way. So that runs freely enough when it's on there. Okay, with the inner washer sorted, we move on to working out how thick the outer spacer needs to be. So I've got a split pin in the hole here, and I need to know how big that gap is to work that washer out. Well, I've got a gauge block stack here, which is 2.9, so that's happily sitting there. So I need a washer that's a bit less than 2.9. And as luck would have it, I have one that I made earlier. So that can go on there. Sorry, my hands will be in the way of this, I can't really avoid that, beg your pardon. But anyway, so that can go on there. Get that split pin back. So he's going to go in there. Like that. So that's all good. So I think I mentioned previously that I need a 4.4mm spacer to hold the flywheel in the right place. So we'll just get that in there. And we should be able to get the flywheel on. Like that, and let's bring the light over to this side. Hopefully you can see that the gears are now lining up. Right, so that's got the end float sorted for the flywheel and the gears. End float for the crankshaft isn't fixed yet though, obviously you just saw me slide it in. That happens when we drill a hole through the flywheel and pin it to the crankshaft. So now we've got the rocker arm going up and down. So I expect you've noticed that I drilled and tapped holes to get oil onto the crankshaft bearings, both sides. These are just temporary screws. There's an M4 thread at the top of the hole. The bottom of the hole has a 1mm hole in it, so it's a bit of a needle point hole. And I've just put some drops of light oil on the crankshaft bearings and on the rocker arm shaft, and now it runs pretty freely. So quite happy with that. So I think my next move is going to be to make the spring that goes underneath this rocker arm. And then I think that's pretty much finishes the, well, it does finish the valve train, and there isn't much left to do in the moving pieces department. I've got to make a cam to go on here, which will be for the contact breakers, but running out of moving parts to make. To make the ignition cam, we turn up a disc to the right OD and ream it to be a good fit on the crankshaft, and then machine a flat on it. So the drawing calls for a 9.5mm wide flat to be machined there, and according to my maths that means I've got to do a depth of cut of about 1.4mm. Well, I think I'll come down to millimetre and then see how things are going. Well, that first pass at a millimetre depth of cut brought me closer to the final width than I was expecting. As you can see, I'm about 8.7mm. But I suppose, given the nature of the shape, incremental increases in the depth of cut start having a proportionally less impact on the width of the finished cut face. So I don't need to panic just yet, but according to my maths I've got to go another 0.4 deeper. So we might do that in a couple of passes just so we can keep an eye on it. I don't know just how critical that width is. I doubt that it's that critical. Nothing else on this thing has been particularly, apart from the fit of the rotating things on shafts, everything else seems to be about, oh, a bit, you know, about this, about that. So anyway, we'll do another pass to increase the depth of cut by 0.2, and I'll see if I can do that without spraying coolant everywhere. I should say the reason I want to use coolant is that that's 4140. It's actually fairly, well, I think it's 4140, but it's actually pretty tough material anyway. Right, we're on 9.3. We're getting close. We're shooting for 9.5, so I think I might just have to trust my maths here. No, I think I'll I think I'll wimp out and do 0.1. So let's go at 1.3 from my 1.4. So I think after that cut, I've got maybe 9.59, not about 9.6 probably. It's a bit hard to be precise with this, but I'm going to call that close enough to the 9.53 I was supposed to be shooting for. I'm glad I didn't go full depth on that last cut though. Okay, so let's recheck that now I've had a proper clean up. I've set the calipers to 9.53 as you can see, and because this is actually quite difficult to measure, I think you can see I'm pretty close one way or the other. It's pretty hard to measure. I don't think I'd be under. If anything, I'm slightly over, but I don't think it's enough variance to be concerned with. So now, slippery customer, come here. Now I've got to take it out of the vise and turn it over, put it back in, and drill and tap a hole for a clamping grub screw. So let's get on with that. So that's got it drilled, tapped, and fitted. And I was worrying unnecessarily about the width across there, because the instructions also call for the sharp edges to be rounded off there. So anyway, there we go. So that's got in there, nice fit on the shaft. And when we're ready to get it lined up, I better nip that up with the grub screw. Alright, that's the ignition cam done. Time to move on to working out how to fit some ignition points. As you can see, I've now got the contact points installed, the ignition cam installed and the condenser installed, and it's all wired up with a 12 volt coil, so we can give it a test and see if it produces a spark. It might not be that easy to see the spark, so I'll do it first up with this lighting, and then maybe do a quick bit with the lights turned low. But it is sparking nicely. Perhaps it's better, I don't know, perhaps it'll work out easier to see in that lower light condition. Anyway, I can move on to the next bit now. So I'm getting set for my first crack at making this rocker arm spring. It's basically a hairpin shape. I'll just include a little picture of it for you. And it's made out of spring steel. Now, I've never worked with that material, but I suspect I need to drill it slowly so it doesn't get overheated. You can see a little bit of it sticking out there. It's 0.3, what I'm working with is 0.3 millimeters thick. It's supposed to be 0.25, but that was the best I could do. And I thought I'd have my best chance of drilling it, because it's really quite thin material, if I sandwiched it between two sacrificial pieces. So that's what I've done. There's a couple of sacrificial bits of wood there, so I can just drill straight through. Now the drawing calls out for the hole to be inset about 4 millimeters, but I'm going to drill it 10 millimeters in, because I'm thinking that the extra bit sticking out past the fixing screw will help make sure it stays flat alongside of the side frame. Well, if it doesn't work out that way, I can always trim it off. Anyway, let's see how we go. I'm not sure what speed to go at here. I think I was thinking something like 400. I really don't want to be going fast, so I might have to switch over to the back gear. I think I've hit the steel now. Well, that seemed to go through it pretty easily. No dramas at all. Alright, well, let's pull it out and have an inspect. Well, that seems to have worked alright. Fairly neat little hole in the middle where it's supposed to be. Alright, let's go and try it on the job. Well, I think you can see that worked out pretty well. Actually, this end of the strip was cut off at a slight angle, which I didn't notice, but I'm not going to worry about it. Anyway, so that screw's holding it down just nicely, and it's staying flat along the line of the side piece, which is really good. And now I've got to work out how to put the bend here to bring it back in the hairpin shape. I have to make up a little jig, I think, to make sure I get the bend where I want it, and with some control over the radius of the bend. It's probably not at all critical, but try and keep it looking tidy. So this is the little jig I knocked up for bending the spring. I've set it up with a 6mm diameter dowel pin here. The diameter of the bend is supposed to be 1/4 inch or 6.35, and I don't know how much to allow for the spring anyway, so it's a slightly undersized pin. I might have been better off using a 5mm diameter pin, I don't know. Anyway, and I've set it to be 40mm away from the centre line of the hole, which is what the drawing calls for. So now we've just got to pull it around and hope we get somewhere near what we're looking for. Fingers crossed. Put the tension on that. We've obviously got to go around quite a bit more than that. Perhaps if I put something a bit more solid into the bending effort, something like that. No, that didn't make any difference. I just clearly need to be able to go around quite a bit further around. Okay, let's see what else I can come up with. Okay, so I've trimmed some of the excess off this to make it easier to handle. I've cut it long, so I'll reduce it to the correct length when we're finished. I think I might have a go at doing this with the Bernard's parallel joint pliers and see how that goes. See if that's any easier to manage. Alright. Okay, well, playing around with the pins and the vise didn't seem to be working, so I've come up with a new approach. Just a bit of scrap, and I've machined a crude die. I just drilled a 5.5mm hole and lopped the top off and opened it out. So, and that's my 5mm dowel pin. So I'm going to press that in and see what that does for us. Looks like it's I haven't made the die quite full enough to allow it to go in. But let's see. Yeah, it doesn't seem to make any difference. Looks like I have to open the die out a little bit. So I've opened the top of the die up to 5.7mm, so let's see how that goes. Oh, that's looking a bit better, isn't it? So, how to close it up more? Use these oddball pliers. They've got a circular anvil, it's the wrong size, and anyway, let's see whether these will put a bit of a squeeze on and bring it closer. Hold those down. Oops, I might have gone too far then. I think if I put that in the vise and get that kink out, we'll be about there. Wow, that turned out to be a lot easier than I was expecting. I just gave it a very light touch to test the idea and it fixed it, so you didn't get to see me do it. Anyway, that's the 7 degrees slope behind it. So I think we're good to go with that. And I'll put it on the model. Okay, so that's got the rocker arm spring finished and installed, and that's doing what it's supposed to do. On the springs, I actually found a spring which is correct weight. It's 0.013 diameter coil, 7 turns. So that's a good start point anyway. Right. Well, I'm quite pleased with my progress. It's starting to really look like an engine now. So we've got the valve train complete, got the ignition system complete, got compression, so we've got compression and spark. All we need now is fuel. So in the next episode I've got to start paying attention to what to do with the carburetor, and also some lubrication points, and I'm sure there's other stuff as well. Anyway, hope you found this episode interesting. Thanks for watching anyway, and hopefully we'll see you in the next one. If you haven't subscribed, you might like to do that just so you don't miss out on the next episode. But in any case, cheers.